It's kind of ironic, isn't it? Sitting in the dark, trying to make sense of how the code works. So I want to do some improvements on the code, and especially the calibration part of the code. So therefore I have dug out my FTDI cable. It's just a USB cable with a serial bus on the other end. And then let's try get the microcontroller to put out strings of data so you can see what's going on. Now we have to do a compromise because the serial data is conflicting with the display, so we can't update the display and have serial data at the same time. And I've worked all evening to find out why I can't get it to work, so now I know that this cable is working because if I connect the RX and TX together on the cable, I get a loop back. But now it's middle of night, so I will continue tomorrow and let's get this thing working. Okay, I made a classic fault. This is like pin 11 on the end there. So, and I've soldered to what I thought was 15 and 16 because the first one I count is not a pin, it's a link. So yeah, I will move those and it will probably work. Look, this is the high voltage part and here's the low voltage part, and you can see the gap there. Yeah, that's not great at all. So yep, we got something going. Never mind, it says reset, but it says something at least. So look, I'm doing an infinite loop while one, so let's try not do that. Seems to be working so far. So this is without the debug. Just bring in the magnet. So the heater is not working right now because I've disconnected it. You can hold these and then you get a menu between calibrate or config. So if you go to calibrate, it just exits. So because I haven't made that yet, so config is the old config, P, then you adjust P, and then you go, oops. So that doesn't look very good, does it? So hold on. So here in the header file, just edit this, do another export compiled, and while that is going, go to MiniPro, open the file, paste it, program, let's see. So it's programmed, but you can't see anything on the screen because now it's sending it here instead. So right now it says cradle and 0, the number it's measuring. And there you go. So it used to be a lot of data coming all the time, but I have a piece of code that checks if it's the same data, it doesn't paste it out on the serial port. So when I push the buttons now, you can see that I can adjust, and so push both of them. You get the fan mode, get out of the fan mode, hold them, get the config, or calibration, hold them. Okay, so I haven't made calibration yet, so config, so now I'm adjusting P, then I, and so on. So today I'm gonna play with the linear interpolation. So there's a function in Arduino to make linear interpolation. It's called map. You can also download spline functions, but yeah, for this task it's not so important. So let's fine. Arduino. Let's go. So if I turn it on now, we should see something, shouldn't we? So this is how it works, this map function. It's very easy. Basically says that if you put an I value of 1, then the new value coming out will be 10. If you put in 10, you will get 100. So what do you get if you put 5 in here? Well, if 5 is between 1 and 10, then it will be between 10 and 100, so 50 I think. So there you go. 0 to 10 is the same as 0 to 100. Also note that I haven't put in 0 values, so that's interesting. That is something that didn't work with the spline function. Now spline is a different beast, and I can do curve fitting much better, but there's a hitch there. So of course on GitHub you can find everything. So and this is a great piece of code. You can do generate step functions, like you can make linear interpolation and then use some stuff to get splines. Now the problem we have with this one is for all splines, values requested outside the defined spline bounds, right, bounds, will return the value of either the start or end point. So, so if you have a function that looks like this, right, then if you try values below that, it just goes right out here, and then values above this bound. So that's not good. Does not. This is the map function. It's in the Arduino reference. Does not constrain values to within the range, because out of range values are sometimes intended and useful. Since this function is very linear to begin with, but it's a bit quadratic, but that's a bit, very little. So I think this mapping function will be enough. We don't need spline to do this. So the map function is really short also. So you can see here, that's basically what it does. So this is the beginning of the program. So what I've done is I've started hacking on it. So this is not the real code. Just one section of the beginning of the code to do something such that I can see what's going on. So what I have is a set of x points and a set of y points, and then I have a total number of points. So every point has a pair, xy pair, 2, 2, 4, 4, 8, 10, and 10 and 100. These are 3 sections. Actually there's 4 points, but we say that it has 3 sections because the first section is 2 to 4, including the values below 2 for x. Then the next section is 4 to 8, or 4 to 8, not including 8, by the way. And then you have 8 to 10, including every value above 10. So I have a little search algorithm, and that's what I'm testing here, that I'm actually getting what I'm looking for. So if I switch it on, no, click there, switch it on, and the microcontroller spews out this data. So basically I'm testing I from 0 to 12, and the reason for that is because I want some values outside the range, the boundaries. So, which are 2 and 10. So here you go to 11 and 12. So what you can see, 2 and 4 have the same y values, and therefore you should get a 1-to-1 mapping. So I equals 1 is 1, I equals 0 is 0. Note that they are outside the boundary here, and it still works. So because we are in section 0, and 4 is 4, and then I have done this on purpose, that 4 to 8 is 4 to 10 when it's mapped. So 4 equals 4, 5 equals 5, 6 equals 7. So it's starting to rise faster now. 7 is equals 8, and 8 is now in the next section. So let's see, 8 is 10, and 10 is 100. So 8 is 10, 10 is 100, and everything in between, which is just 9, is 55. So you can see I between 8 and 10 is mapped differently. It's in a different section of this in my x values. So yeah, but maybe I don't want the section to look like this. I want rather to have like a function like this, ADC to temp equals, and then it converts the analog raw analog value. So let's do that. So let's make a function. Let's find a good name for it. ADC to temp. I'm not so sure. Well, it's very accurate, but this function is actually more like piecewise map. Yeah. Let's go into the header file. I'll find a place for it. Let's just put it here. Load piecewise mapping. So, but right now we are hard coding it to uint 16T because I think that is the ADC raw. So let's see, ADC raw is uint 16T. Okay, so yeah, so that's what it wants. Maybe I should return that also. Uint 16T, right? So let's work with x. So yeah, so the C parameter is like a config parameter, I think. So it has a minimum, maximum, and default, and where it's supposed to be put in the EEPROM. But for now, I'm just going to hard code it. You can change that later because I don't understand that right now. So data for piecewise map function. Yeah, you also need to know how many data there are in that, and then we can put all of this into a function. So yeah, so let's put it in here. Uint 16T piecewise map uint 16T value of x followed by some code. Uint 16T piece. There we go. Let's just copy that. Make sure I'm in the same. Yeah, so it's the same, isn't it? Yeah, that looks the same. Then we will return a uint 16T. This is casting of this map here, but instead of I, it's supposed to be the value x, which comes in the function. So let's compile, see if that works. Probably get some errors there. Yeah, that's okay. This is not useful anyway. So yeah, okay. So now we don't have any section anymore, but that's okay. So look, it got a bit less cluttery now that we put everything into a function. This is the reason we're going to do this, is to, yeah, we don't have to actually try and find out what the section is, so sorry about that. Yeah, it's x, you know. Let's see, I have some warnings, but it does work, so let's export it and import it. Standard. Okay, program. program, it's programming, see what comes out of it. There you go. And it does look right actually. So we have 8 equals 10. No, is that correct? Let's go up. 8 equals 10, yeah, and then 10 equals 100. Yep, it's working. It's great. So now we have a mapping function. So now, in order for us to calibrate this thing, we can just change those points. What's going on here? We have this EP load and stuff. Well, if I switch it off, let's clear the screen, switch it on, you can see it loads all the configuration. These values inside the parentheses is EEPROM values. So when it says config, it will go into config. If it says cal, goes into calibration, so hold both buttons. H0 is actually X0, but you can't write X, you know, so let's set it to 47. Now you can see that 47 was saved to 31. And how does that work? Well, first of all, I've defined a set of default values for temperature calibration. And here you can see I have put my calibration array, which are 5 items, and then you have all the positions in the EEPROM, high byte, low byte, and then when you get into calibration, if it's a config menu, it will start with the config, but if it's calibration, it will ask for values for H0. So that's very nice of the author who made this program. Change config parameter and you just give it that cparam data. So let's see what happens then. So I haven't changed anything in there, I think. So that's the beauty of this code, actually. So here it takes care of all the human interface. So, and then well, it saves. So, and what the hell? Why is it like this? Something must have happened to my code. So, and why did that happen? So let me just press Ctrl Z here. Set. Oh my god. So this is a live sort of disaster movie. Well, Ctrl Y. Let's try and compile it, see if it works now. So you can see we can save different parameters like this. So just give it a parameter with a reference to its address. Yes, I think it's almost ready to be tested. But first, I think maybe this conversion has to be done with the new calibration. So let's make a new temperature instance line, which doesn't have this micmac. So let's call it piecewise map ADC raw, and that's it. And right now it's 1-to-1, so it will behave very strangely than before. So, but first I need to open this thing and connect the heater again, and then I will connect the temperature sensor there. So yeah. Okay, so I feel like I'm done filming the code now, so let's try do this in live. So I've switched off debug there. So there you go. Let's see how this goes. Config seems to be working. Get in there. It says H dot actually. I don't know why. Then it says H dot again. H dot again. Okay, so number representation has to be different than this. So when it gets to Y, it's 2 dots. So let's get that fixed. 400, and then it should exit. Yeah, default value is a dot. Okay, so this is the progress so far. I'm getting a bit tired of it. This is the ADC value, averaged. Now I'm about 400 degrees. So I can go a little bit higher, but not much. I don't want to break this thing, so... Okay, now it's starting to make noises again, so... yeah, 400 something, that's okay. So, but this value here is 630, and it's supposed to go to 1000 when it's overloaded, or if it's the high end. So I don't know if we're going to do anything about it. So what I did was to adjust the cal screw all the way to the right, and what happens then is that the actual temperature that you measure will yield a lower value here, so it gets closer to the actual value. But since we're not sure if that's a good thing or not, so but now I've set it to that. So it shows 407, and it's not too far off the set point. So let's go to set point 400. So it's not too bad. So these are the values I've used. So if there's some particular value you want to calibrate against, like 280 for example, if that's an important value for you, you can put 280 here and then read out the ADC. So I have 255 though, so it should be fairly accurate at 255 if I manage to put the the measurement in the correct place. You can see it's very touchy, you know, so now I'm moving it around so making a mess of it there. So let's get out of the fan. Oh, this is a bad video. Yeah, I know, it is a bad video, I'm sorry. But this is what I've done, and it works for now. And don't pay attention to this, pay attention to this. 255 was the set point. And I have calibrated against the set point, so let's see, 255, let's see. 255 should be 355 in ADC values. So here you see it swings around there, it goes down again. And over there you see 255. 256 and oscillating a little bit. So you can see it's very close to that. So 260 is maybe a more important value. 270, so see how that goes. It seems fairly okay, so let's try something else like 350. Now when I go to 350, hold on, it will be in a different range, I think. So 350 is actually it's in the same range, so let's try 380 then. It's in the same calibration or in piecewise interpolation, so range, whatever. So this is a different calibration, so it doesn't seem to get up there, or maybe it takes a bit of time, or this one has moved. No, doesn't seem like it. So yeah, so when you calibrate, sometimes maybe you don't get the exact value, so you can see it bounces a bit up and down, you know, so it's not so easy for me to figure out what's correct. This bouncing up and down you maybe can tweak if you go into not fan, but okay, config, and you can tweak these values. So this is how fast it goes to the set point, so we can try 610. What I was going to say before the camera broke down was that you can get into config. Okay, so when I get into config, you can see that the temperature is dropping. You have P, I, and D. Okay, now let me start over. I wasn't going to show you config. So just get the temperature down. So okay, that was fan, config, into cal, both buttons. So the first value is 148. So that's the one on the top there. So you can actually adjust it in here, and then you just the second one, the third one, sorry for the display mess there, and the fourth, and then I think it's the Y values. There you go, 127, that's the Y value. So you can actually do it in here. So I have to figure out how to get Y on the screen. So yeah, and also you saw a dot in there. That means you have a default value. It's outside the range. So but I think I will give this a break now and end the video. And if anyone's interested in code, let me know. Let me know. So you see, I was up in 400 something degrees, and then when this calibration screw was a bit down, I think this ADC value went over 1000, and I can hear ticking noises in here, so I think I overheated it. Something happened anyway, so I'm staying away from like 500 degrees. It's supposed to work at 500 degrees, but what the heck, if I need 500 degrees I have a heat gun, so no problem. Yeah. $150, yeah, so this calibration thing is now no longer aligned, so yeah, okay, I give up now. Thank you very much for watching, and see you another time. Bye bye. To show you that it's working okay, so set it to 270, and it shows the actual temperature, not the fake one. But it does have a lockout at 3 degrees off, as you can see. kind of jumps around 70 and 3 or 67, so that's just to give a more stable number because it is oscillating. So, but this isn't bad, so but now I can trust this number since I've measured it. So 300 or 290, not much overshoot at all, so I'm happy with this.